I'm Erica Salazar Mullins, and I'm coming to you today from Ventura College, where I'm a professor in biology. I teach cell and molecular biology. I'm also a PhD student at Virginia Tech, and my PhD work focuses on curriculum and instruction, and particularly with integrative STEM education. So I'm hoping to give you a little introduction about what that entails and what my observations and the sorts of things that I think about in relation to helping to increase or enhance a sense of belonging and agency in students who are historically underrepresented in the STEM fields. So what I hope to accomplish today is by the end of our time together to leave you with an understanding of what technology and engineering design-based learning is. And you'll see that abbreviated often as TEDBL. And we'll relate that to design challenges and talk about what a design challenge is, what they look like, and specifically from the framework of using an integrative STEM approach. So operating under that pedagogical framework of iSTEM Ed. And we'll also cover some of the rationale and the methods that are used to develop those sort of challenges. Next, you should leave with an understanding of some deeper insight into some of the pedagogical strategies that are used with iSTEM Ed specific to the TEDBL challenges. And we're going to do that by discussing a scenario where we'll kind of go about some of the early stages of how one of these activities would look. We'll talk about how to apply these concepts. They can be used across a variety of settings. My particular interest is in using environmental and climate issues that are place-based toward a lot of the intersecting identities of our BIPOC students, specifically relating to that sense of belonging and agency. And then finally, we're going to talk about some challenges and some opportunities where we can apply this method specifically and thinking about it more on an individual basis to your location and your campus. What are some potential strategies that you can use? And also what might be some challenges, how would you overcome them, and where are there opportunities to partner with other folks, including agencies like NGOs or other campuses that might want to collaborate in your community. So to begin with, though, I just wanted to take a moment to kind of center us on the landscape and what we're thinking about. So my idea here that I'd like to introduce you to is just to use the specific practices in pedagogy to support a sense of belonging and agency in students. And I have some ideas that I'd like to share with you, but I do want to acknowledge the fact that we are here today. We've come together to support equitable practices that empower our students and our fellow colleagues. And that even when we're in the best of times, that can be really hard to do, especially when we're facing global injustices toward humanity that we're all faced with right now and that are really heavily on our minds. It can be that much more difficult in the face of those sorts of things that are happening. So as we start to think about the hard work that comes with change making, I wanted to take a moment just to sort of center, regroup a little bit and think about humanity and the reasons that brought us here today. So if you'll indulge me a little, I would like to practice acknowledging the similarities between ourselves and others. And that can mean however you want to take it. It can mean maybe even people that we might have conflict with ideologically about and things that made us feel passionate and brought us here today. And I want also for us to focus on our differences and realize that even when people seem very different from us in fundamental ways, they're still people. And then using that to think about the basis of real connection. So if you would follow with me for a moment, I want you guys to just to think, kind of just take a minute to yourselves and relax a little. Let your body settle in where you're sitting and find some comfortable position. Just invite in a sense of ease and relaxation throughout your whole body. And just for a moment, just take a couple of full, deep breaths that extend all the way down into your belly, keeping everything soft and settled and relaxed. And hopefully, you'll start feeling grounded by the weight of your body against your chair or wherever you're seated. And as you're relaxing and settling into that seat, I'd like to invite you to soften around any areas that feel a little tight. Drop your shoulders, soften your hands, relax the muscles that are in your face and your jaw. And if you feel comfortable with it, maybe even sort of gently close your eyes or have your gaze look downward just so that you're not visually distracted just for a moment. So as you're settled in, allow yourself to take a deep breath in and a long breath out. And as you're breathing out, allow a sense of releasing any tension that you're holding on to. So as you're breathing naturally and relaxed, I'd like you to briefly scan your body with your awareness and notice any sensations or emotions that are bubbling up today. Just noticing what's kind of on the forefront for you and inviting a sense of spaciousness and acceptance for whatever you're experiencing right now in your body, your emotion, your mind, and acknowledge them without judging anything good or bad or right or wrong. So now what I'd like to do is bring someone to mind, maybe who you don't know very well or who seems very distant from you, very different from you. And as you're bringing to mind that person that you might know very well, notice if you experience any shift in the sensation in your body. And holding that person to mind as if they were right in front of you, I'd like to invite you to say to yourself, this person has a body and mind just like me. This person has feelings, emotions, and thoughts just like me. This person has at some point in their life been sad, disappointed, angry, hurt, or confused, just like me. This person has in their life experienced physical and emotional pain and suffering, just like me. This person has experienced moments of peace, joy, and happiness, just like me. This person wishes to have fulfilling relationships, just like me. This person wishes to be healthy and loved, just like me. Now take a moment to sense how you're feeling. And as you hold this person in your awareness, notice, what do you experience? And keeping that person in mind, send them good wishes. May they be well. May they be happy. May they be healthy. May they live with ease. Now shifting your awareness back to your breath, breathe in and breathe out and reconnect with your body, feeling present in this moment and alive and connected right here and right now. And when you're ready, I'd like to hold on to that feelings and feel a little more grounded and centered, and then begin to discuss the work at hand. To begin with, I'm going to ask you When the last time you felt like an insider was, and when the last time you felt like an outsider was. And that can mean different things. It could mean places, it could mean times, um, all manner of things. But I'm gonna stop sharing for a moment and drop a link into the chat for you. And I'd like it if we could go and join together on a Jamboard. And as you'll notice, there's some prompts up here. What does belonging mean to you? I would like it if you could describe a time or place where you felt like you belonged. And then describe a time or a place where you felt you didn't belong. And so let's just take a moment to do that. And if you haven't used a Jamboard before, you can grab a sticky note and you can type an anonymous message there. And then when you save it, it will appear on the screen that you're on. That's a nice one. Yeah. And you can drag the notes around any place that you would like them. Yeah. You can even change colors. You can draw. Um, yeah. Yeah, belonging definitely has a lot of different meanings for people, and even in specific contexts. You can feel completely at home and as if you belong in one place and very much feel like you don't in another. And I think it's important to acknowledge that that can shift, especially when we're thinking about the environments that we create and the values that we communicate to our students. Oh, that's a really good one. Feeling like I can speak and be present, and some people are glad I am there. Yeah, this is great stuff. Let's check on the next one too. How about a specific time or a place? Didn't even think of a time. I think for me, it might have been starting grad school. I'm not sure I felt like I belonged just yet. Um, but yeah, for sure. Hopefully we all feel at home with our family. That's a good one. Yeah. And hopefully also with our colleagues and in our own classrooms. And the other one might be a little bit more challenging when you think about a place where you felt like you didn't belong. Yeah, these are beautiful. Yeah, so I wanted just to kind of think about things, because I think when we can tap into the idea of what belonging means to us, and we all can remember times when we felt we belonged or maybe didn't belong, I think that that helps us to consider how someone other than us might also be able to relate to that. So I appreciate what you've done here. I also wanted to share another link with you. We're not going to be using breakout rooms today. Instead, we'll be operating often from a Google Sheet, or Google Docs, sorry. And that's going to have some contact information on it, some additional reading for you, as well as a copy of today's slides. So if you want to at any time, we'll hop around back over to that. But I wanted to make sure that you had that before we moved on. So thank you for sharing with me. And let's move back in to the slideshow. All right. So belonging, self-efficacy, and agency. There's a intersectionality on these topics. So I'm framing this from the context of environmental issues. And then also within how that influences the educational setting as well. So when we're looking at what the literature has said, we know that selecting and persisting a STEM major or persisting as a STEM major is influenced or impacted by a sense of belonging, self-efficacy, and also agency. And when I'm using this word self-efficacy, I'm using it as it was defined in the literature, where it's a sense that you have power or the ability to influence your immediate surroundings. In other words, you feel like you have control over the situation that you're in, or your surroundings. And so belonging, uncertainty and self-efficacy both can negatively impact whether or not a student decides to both pursue a STEM major as well as to stay in it. And part of that is self-perceptions as well. So when there isn't a sense of community for students, the literature tells us that students tend to have a perception that maybe they don't belong because of a metric that they've perceived. Like, for instance, even though they might be getting strong grades, their perception might not be that it's adequate enough. And when there is this community and a student feels like they belong, and that they can identify themselves as a STEM major, then that's less likely to happen. And retention rates, therefore, would be improved. A sense of agency relates to that. So self-efficacy relates to a lot of things, right? It can be like, I am a STEM major and I can do well and I belong here. But it can also be applied to areas outside of the school, like in the community, particularly if that community is facing challenges with climate change or with different environmental concerns. And that really, I'm sorry, I have a slight little problem here. My apologies. I just lost my browser. Sorry about that. Okay. All right. So specifically, can you guys see on my screen okay? Is that okay? Okay. I'm actually still having problems with myself. My apologies. Okay, you see it okay? All right. Um, so how this relates to environmental justice. Climate change and environmental racism and public health disproportionately affect our students who are also historically marginalized in the STEM disciplines. And we've seen in the literature that when we have justice-oriented pedagogies, it helps students build up confidence to engage in those issues. Um, we've also learned through the literature that often when we approach environmental justice issues from the framework of fear or with a sort of a crisis mentality, then what could happen is it actually shuts students down, and they become disengaged from the material or the topics. They become anxious. They become even depressed. And so thinking about framing some of these issues that are challenging us most now from the context of action and activism helps students to engage more and also to feel like they have some sense of agency and they're able to take action. So it goes beyond just thinking about the problem, but also helping our students to become educated on ways that they can act, and helping to create opportunities for action, so that they build through that confidence that they can do. So there's been a call in the literature for what's termed as eco-social work, particularly by young folks in particular. And what that is it's capturing this idea that when we view issues that plague us in terms of the climate, and all manners of things like pollution, and global warming, and these dynamics that we have seen happening in our environment, and we couple it with activism, then and thinking about the people who it is that this is affecting the most, then it's empowering to our students. My position is that it also allows students to consider applications of STEM directly. So often, particularly at the undergraduate level, we may talk about issues, but we aren't necessarily giving it the contents or context rather of how we can go about addressing them. What are some applications? What is some current research that's going on in the field? But also, what are your ideas as students, as someone who is young and living in the moment that we're in, who most likely has experienced firsthand with the ramifications from some of these issues? What is it that they have in mind with ideas that can address it? And so with that, I'd like to think about how that relates to integrated STEM. So there's a few different categories. So when I'm talking about integrated STEM education, oftentimes we throw around this word STEM, and we don't really necessarily think about it too much, and unpack it. If you're a science person, you're probably thinking STEM is science. If you're a math person, you're probably doing the same thing. Well, math is STEM. But that T and the E in the middle, the technology and engineering, don't get quite as much love, and they really can unite both science and mathematics. So thinking about all of the letters in STEM, then integrating them is using one area or one discipline in support of the others. So we can do this through content integration, first of all, meaning that if I'm teaching a science class, for instance, maybe I'm teaching chemistry, and then certainly I can use technology, engineering, and mathematics, and even other disciplines within STEM, within the science part, to support my students' learning. Also integration. So supporting content integration could come through things like design challenges. If I gave you the context of an environmental issue. Could you use technology or engineering to support understanding of science or mathematics? And then context integration is where that application comes into play. So in other words, setting the stage for disciplinary exploration of whatever our discipline is, by using technology and engineering to deepen our understanding of it. So I'd like to spend a minute thinking about some environmental concerns in your own community. And if you would join me back over on the link that I gave you, then let's identify some issues. So what I'm looking for in particular are areas that you've identified in your community as environmental justice issues, and what those potential impacts could be from these issues, as well as who the affected parties might be. Now let's just take a moment to work on this. Yeah, these are some really important ones. Yeah. So as we're starting to fill in this table, I want you to notice some patterns. Of most of the topics either relate to the air that we breathe or the water that we drink. And then some contamination of either of those substances. And these are pretty fundamental rights we have as humans, to have clean air to breathe and clean water to drink. So they're definitely issues that affect all of our students as well as us and our colleagues. And these often come under the heading of what we consider to be wicked problems, meaning that there isn't an easy solution to any of these problems. There isn't a one size fits all or perfect answer to addressing them. But certainly, the more that we have people joining us to think about these issues and to think of potential remedies toward them, then we're stronger in numbers. And these are often issues that feel overwhelming. And it makes it seem like as an individual, we can't conquer it single-handedly. But this is where I believe that addressing these issues and thinking about potential solutions collectively will help students gain that sense of agency. So I'd like to appreciate what you have so far, and I'd like to come back over to the slides for a minute. So with these environmental concerns in mind, I'd like to introduce you to the idea of technology and engineering design-based learning through design challenges. And I think one of the strengths of these design challenges is that you don't necessarily have to be a so-called STEM person to do them. So there are plenty of students who are not currently STEM majors who can definitely add to the conversation when they're thinking of an environmental concern, and they have embodied knowledge and lived experience to contribute to coming up with a design that would address or mitigate some sort of concern that's related to our environment. And there's plenty of different examples that we could use with applied science. And I want to kind of take my care here to differentiate. When you're thinking about applied science, you're reasoning through theory and developing a theory-based application. And that isn't necessarily what I'm proposing. What I would like to frame it as is that there are plenty of examples that we've seen where applications have been developed without theory, just because of an understanding of the way that the world works, or internalized information that we all accumulate from being humans on this planet. You can look at a problem and then your own perspective can bring you toward conceiving some sort of idea that might remedy that challenge. And it's in with that spirit that we're coming to this. So one example that I'd like to start off with is the idea of an algae bioreactor. And what has been proposed in the past, there's been some widespread idea that using algae to create clean, efficient fuel might be good in times of crisis, particularly in developing nations where they don't have access to the supplies and the technology that you would need for clean, safe fuel if, for instance, power was out. And so using fuel that's been produced by algae, then you would harvest oil, and then you could use it for powering things like lights, and just to keep the very basics on, because there's plenty of things that we're experiencing where the power grid might not be stable. And this is definitely proposed as a situation. So I'm curious to ask if you guys want to either share out or drop in the chat. If I asked you to design a biofuel, any kind of a system that would generate biofuel, and it would be algae based, what are some of the things that you would need to know to begin to design that process?
Which algae you're going to use.
Yeah, for sure. So we need to know something about the algae in terms of like what's traditionally used, what the oil content is. What about growth conditions?
Yeah, and if you're going to produce around the clock, growing your algae, you're going to have to come up with some sort of light source to keep things going.
Yeah, and then what do we grow it inside of? Anybody else? Can you think of, yeah, how much fuel can we get out of it? How much energy can we get out of it? How do we transport it? How do we store it? This is awesome. Anything else that you guys can think of that maybe we would need to know?
Whether or not it's going to be centralized or decentralized.
Yeah, that's important too. Yeah. So, yeah. So yeah, and then scaling. How can we scale this? Is this something that an individual can do? What kind of access do they have to materials? There's a lot of things that we would need to consider. And so I want to walk you through an exercise, and it's one I actually had to undergo through one of a class that I took on this. And by doing that, I'm hoping to sort of model some of the components that you would include in this sort of activity. So let's go to G1. Okay. So when we're thinking about using this and scaling this up, any type of a design challenge, this can be done at a couple of levels. First of all, it can be done in your classroom. This can be a lab or a lecture exercise, but it can also be scaled up, in my opinion, to include a little bit larger group. So where I might envision something like this is, imagine that you have freshman orientation day, or you have some sort of campus STEM event. You could incorporate a design challenge that way, that might draw in students who are considering STEM, or maybe on the fence about deciding to either declare that they're STEM major, or that they're maybe wanting to stay with it versus something else. So one of the components that you'll see frequently with this sort of lesson plan is the use of what we call an interactive engineering journal. In this case, this one's specific to algae bioreactors. And we were presented a video that Bill Gates produced that was sort of defining what the challenge was, why there was a need for algae bioreactors, how they could be used. And so we started to think about, why would a design challenge become the correct choice to look at identifying some potential solutions for how to maybe launch a kit that could be used in areas that were prone to having sort of power disruption for various reasons, and why would this be a good way to go? So we thought about things like the context, where the problem is here, and identifying it. In this case, thinking about, there's a need for sustainable fuel that's affordable, that can be used in virtually all settings. And if we're thinking about engineering and defining it as a discipline that can be used to help develop solutions for humanity, that address some sort of human need, then certainly an engineering challenge to find a solution for this problem would be warranted. So then we begin to think about what we know versus what we don't know. And that can go in two different directions. So maybe we need the biological, chemical, physics, mathematical knowledge, but we also need technological technological knowledge. It's one thing to understand that this might be a really great thing to develop, but and we know, like, okay, we need this algae is the best one to use, and we definitely need lights, but then how do we put all the pieces together? And so there might be different components that we could look into as part of the project, where the student is actively sourcing materials that would be appropriate for this sort of project, as well as coming up with a design. And oftentimes that design relies on some fundamental knowledge of engineering or mathematics, not just the chemistry, physics, and biology of the solution. And so it ends up being that a student is nudged to start to do research and look into what it is that they might need. So then eventually you'll get them to this place where they might have an initial design. So maybe they're thinking about a solar powered light would be the way to go, because if we're trying to generate energy, then it wouldn't make sense to have a light that plugs in and uses energy. And then they'll look into different designs that are already out there, and maybe think about maybe a fence design or whatever the other options were. And so they know they need to have some sort of container for harvesting the oil. They might be thinking about the species of algae. They might be thinking about what the algae is going to be growing in, and things like increasing surface area because you'll get more of a harvest. And so as those early designs start to flesh out, then we can move on from there and think about some constraints and some criteria that allow us to objectively measure whether or not this is a design that would meet our initial criteria, being something that's sustainable and able to scale. So this is an iterative process. So when we have students potentially working independently and then, or even as teams, and then communicating what they've come up with, their design and their thought process to other students, they might wish to change or modify some of their design features. So in this case, there was a prototype that was developed as a proof of concept. And that's part of the design challenges, prototyping and proof of concept. And then from there, just looking at other people's designs, you might kind of latch on to different ideas. And in this case, here's some notes. That one student made a point of using an airlift that had pressure differential to circulate the algae and water. Someone else considered using a CO2 canister to help maintain flow so that the algae wouldn't get clogged up. And then, thinking about potential revisions. So now here's a little more mature design, looking at the mechanical and technical aspects, and not so much the biological, although, we need things like nutrient delivery, thinking about how to keep these organisms alive and happy so that they'll keep going. Also thinking about the actual structure and the components of the structure, how we're going to support it, how are we designing it. And then moving on to actually constructing it, as I mentioned, that prototype and proof of concept. Instead of algae, this is just food coloring. And these are just PVC parts that were picked up at a local hardware store. That's another view of it. And then considering the materials. So if we are really thinking about humanity here, and we want something that can be widely used, and it's a lot of different settings, then it has to be materials that can either be easily sourced locally, or that they can be packed up into a kit that's easily distributed to people who are in need. And with instructions and tools that are also easily accessible. And so thinking about those sorts of things. Ultimately, after revisions, then we have an actual concept here, and that's it in action. So in this case, this is just an aquarium pump and just a regular old household bottle of water that you could use as your growing tank. And then moving it through the tubes is helping to keep it aerated and moving along so the algae is doing what it needs to do as it's growing. And then we would eventually collect off the oil that it has produced for us. So that is one way to do it. One example, but I'd also like to get back here. I'd like to talk to you about a couple other examples. Do you guys have any questions though about the algae bioreactor? Okay, let me share my screen again. Okay. All right. So from there, I came up with a lesson plan myself. And at the time, I was a faculty member at Cal State Bakersfield, and I was teaching upper division microbiology. And I wanted to revise a unit that briefly touched on the ecology of fungus and give it a little bit more context. That was a medical microbiology course. So human disease was definitely part of it. So I was trying to relate ecological to public health. And so for that one, I'm going to share with you my design brief. So what the situation was here, in Kern County, which is where I was at the time, there's a lot of alternative energy, and especially in the upper part of Los Angeles County that kind of butts up against Kern County. Lots of solar panels going in. And when we have that sort of construction, we're disturbing soil. And that area is endemic for the fungus that causes valley fever. Once it's airborne, it can piggyback off of particulate matter, or the spores can just be distributed through the air, even without being attached to particulate matter. And those are the people that are in the area will inhale those spores, and they can become sick. And in certain cases, there are people who can get the disseminated form of the disease, which can be fatal. It requires really aggressive treatment in that case. It is lifelong. So this is something that's serious. And the issue here that we're identifying is the current method for dust control or dust mitigation when there is construction projects like solar panels or the high-speed rail project that's currently being developed in California. The answer to that is to use water trucks that just spray water down over the dirt to control dust from popping up. The problem with that is that this is a fungus that is dimorphic, and when you hit it with water, it'll vegetate and it'll spread. So there is a concern there, both from an environmental standpoint as well as from a public health standpoint. And so the idea here is that this is a hypothetical challenge. It's not a real one, although I would like to see it be a real one. But I proposed asking students for new methods to control fugitive dust emissions that wouldn't further stimulate the growth of this pathogenic fungus. So it would have to be a method that would be appropriate for use in a variety of construction settings. So not just solar farms and wind farms, but also for road construction or high-speed rail construction. And then students were given some parameters, criteria, and constraints. So they have a purpose. They have criteria that they would need to meet, and then they're given constraints. It can't be pie in the sky, right? It can't be unrealistic design. It should rely on machinery and equipment that is easily available and sourced. It shouldn't be ridiculously expensive, and it shouldn't be composed of materials that would further contaminate or harm the environment. So when you're thinking about designing a challenge, one way to go would be to do something like come up with a design brief, and it really lets the students know all of the aspects that they should be considering when they are going about their design. And I envisioned this and I designed it to be a multi series, so a multi class meeting lecture activity, so that they would work in small groups and they would come up with an idea. But this can also be used in other settings. Does anybody have any questions though before I move on? Any questions about this particular lesson plan? If you're not familiar with valley fever, it does disproportionately affect some people based on ethnicity. You have a greater chance of getting the disseminated form, which is the fatal form, if you are African American or Pacific Islander in descent. And where I got the idea for this is that the California high-speed rail system uses a program. It's a prison to work program where they do have formerly incarcerated individuals working on the rail system as a way to introduce skills that they can learn to get back to work. And I think that that's an excellent program, but I have concerns that it would inadvertently expose people who are susceptible to this disease. And that really kind of undermines the idea here. So that's where the idea came from. A colleague of mine, Jess Amos, is a chemistry faculty member at a community college in Virginia. And she developed a similar type of design brief for sustainable batteries. And she has graciously allowed me to share that with you today. Her information is here. By the way, you all have access to this. She's at Wytheville Community College, and that's on the border of Virginia and North Carolina. And then what she did with her exercise, let's take a look at it. So she was thinking about sustainable batteries. Obviously, lithium ion batteries are used extensively. They contaminate the environment quite a bit. So is there an alternative? So she challenged her students, and this was part of an electrochemistry. It was a lab for electrochemistry concepts in a chemistry majors course. So these students would develop a working battery, and it should be eco-friendly materials that are biologically sourced. So she charged them with considering different battery types that exist, fuel cell types, requirements for the redox reaction, and what type of components that they would need to have access to in order to work on these designs. They were to consider not just the materials used, but thinking about toxicity, after the materials no longer serve its purpose. And she gave them some very specific criteria. So they needed to have an oxidant and a reductant and some form of a salt bridge, so that their battery would be functional. And it should be enough voltage to power a small LED bulb. So there was definitely defined criteria. She even gave them some resources. And what they came up with, again, they were using this interactive engineering journal. So initially they're having to come up with sketches. Just like I showed you with the algae bioreactor, they would also have to come up with materials lists and thinking about what do I know versus what do I not know at this point. So this is a real example of one of her students thinking about what they had access to and how they might go about this. In this case, they were using limestone. We have another one where they used an ice cube tray with some screws and some copper wire, and they placed vinegar in the ice cube tray. We have another student who is quite gifted with graphics, and they used potato using zinc and copper. And they came up with an idea of how that might be able to fuel enough energy to light up an LED bulb. And then they moved through to the proof of concept and prototyping. So in this case, we have a student who used, it looks like blood oranges, and they have a voltmeter, so they're actually checking to see that it's doing what it needs to do. We have our potato, and they're checking that, obviously. Here's another setup with the potatoes. And then this one is a little bit different. So this is vinegar. And we have another version of the vinegar, which is our ice cube tray with vinegar added to it. And that's what they came up with. Any questions at all about that? So I would like to hop back to the document and think about some brainstorming and a couple of areas. So coming back over to our document, I'm wondering if you have some ideas for how you might implement a design challenge on your campus. So thinking about a topic, a general idea for how it would be executed, and a setting. Would this be in lecture? Would this be a lab? Would this be part of an orientation day or a STEM day? So why don't we take a few minutes there to think about that? And my hope is that you have something you can take with you, or have some sort of idea that you might be able to adapt, and some resources. So hopefully I gave you some food for thought, and then we can think about this. There's definitely some challenges to implementing something like this. I mean, both, and it's regardless of what scale you choose. If it's part of a class versus like a bigger, larger scale like event, like a STEM day or something like that. So one of the other things that I would like to consider, is thinking about and brainstorming what origin or what obstacles might you be confronted with, and where are they kind of coming from. Like, for example, just to throw one out there, it takes time to develop a design brief, and to really think about all of the criteria that you need students to think about, and how are you going to measure this? How are you going to assess or evaluate the work? Um, is it going to be a lecture activity? Is it going to be a lab activity? So if you wouldn't mind spending some time thinking about what might hinder implementation of using a design challenge, and why it might be an obstacle. Another consideration is to brainstorm for strategies for overcoming those obstacles, as well as identifying partners and allies. Do you have any fellow colleagues that you can collaborate with on design? Any administrators that might help you to launch something like this for the majors at your campus? Um, and how are you going to go about making it thoughtful, keeping in mind that the idea here is to connect students to the issues that they're facing in their community, and then have some sense of agency by thinking about ways that they can um, work toward mitigating those types of challenges. So that might mean partnering with local government, maybe the city or county where you live has some issues that they're looking for solutions to. Maybe some NGOs in your environment or your local community might also be willing to partner. And then also, in what ways could you use this to connect to the community at large where your institution is? So for example, maybe one thing to consider might be to have like a poster presentation or some sort of event where students that have participated in a design challenge can kind of show off their work to the community and bring in their family or other community members to see what has been done, and allow them to have that moment where they're sharing their innovation. Um, that could be another area where having partners in the community might be helpful. Yeah, yeah, equipment is a big deal too. So and for that reason also funding, right? Having the ability to implement this. And I think that that's where collaborating with folks and getting people on board is definitely something that would be helpful. So in looking ahead, um, I I think that there is potential here for being able to use this as a way to not only allow students to use that embodied experience and that they have to contributing to a design that's meaningful, that has context to their lives and the community that they reside in, that they live in, that they become educated in, that can help not just inspire them to realize that STEM is for them and that they do belong and that their ideas and contributions are valuable, that this isn't just about getting high grades and a certain GPA, and not just having the sense of belonging, but that they have the ability to affect change in their communities, or to at least think about activism and ways that these issues that are so or feel so oppressive and impossible can be addressed, and that there's ways to begin to think about addressing them. Um, and I also think that this is a good community builder, that depending on how it's executed, having the connections that are made through a design challenge to the faculty, to the supporting personnel on campus that participate in this, to their fellow students in the classroom. Since this would be a group project, no matter what the scale is, that helps to empower students to understand that they are a part of a community, and that they do belong and they are valued, and they are welcome. And I would like to see potentially a community of practice. I'm really interested in research specifically to increase that sense of belonging and agency and retention in students who have been historically marginalized in STEM. And to that end, if I pick my right link, I do have some, if you are interested and you would be willing to share your email address or follow up with me, I have my contact information embedded in several places, as well as the slides. And I did leave you with some categorized literature. So some of the things that have been swirling around in my mind as I think about thoughtful ways to use design challenges is that piece looking at climate and how it affects both public health and how it ends up becoming an environmental justice issue. So thinking about self-efficacy, all of these types of concepts that we've talked about. I have some good literature, recent literature that's linked directly from the document. I have some literature on belonging, agency, and self-efficacy as well. And then if you want to dig deeper into integrated STEM education and TEDBL, I also have some links there to some literature that will help you to get a little bit better acquainted with the practices and some of the terminology as well. And I want to thank you and open it up to discussion. If anybody feels like chatting, or if you have any questions, I would be happy to take them.
Where is that document housed that you just showed?
Let me grab that link for you.
Also, if you could please complete the survey I posted in the chat.
Oops. There's a link.
Okay, thank you.
You're welcome.